Hey, welcome to another installment of College Algebra. Today we'll be talking about section 1.5 and specifically going over how to solve three different types of equations that are essentially just quadratic equations in disguise. So for this video, we'll be talking about radical equations. A radical is the fancy name for a square root symbol. Or particularly any kind of root symbol. In this example, it's a cube root. And radical equations are very straightforward to solve. Typically, the goal is to isolate at least one radical on one side of the equation. So as such, to do that, we'll just add 2 to the other side. And that gives us that we have the cube root of 2x minus 4 equals 2. And then once there's a radical on one side of the equation that's isolated, we just want to undo it. And so to undo a radical, all we have to do is raise it to the power that we're taking the root of. So in this case, we're taking a cube root of it, so we're going to raise both sides to the third power. And if you're quick with your cubes, you'll know that 2 cubed is 8. And then when we cube the cubed root goes away. So we get 2x minus 4 equals 8. That tells us that 2x is 12. And finally, that x is 6. So this problem was nice because we didn't have any quadratic show up. We'll see in the next problem that it is possible for a quadratic to show up. So now we want to solve something slightly more complicated. We're looking at the cubed root of x minus 1 equal to x minus 7. In this problem, we already have the square root of x minus 1 isolated on one side of the equation. So we're going to jump right into squaring both sides. So then on the left-hand side, the square root and the square just undo each other. So we get x minus 1. And then on the right-hand side, we're just going to expand. And so as we FOIL out, we get x squared minus 14x plus 49. And now it's looking like something that we know how to solve. On one side, we have a linear function. On the right-hand side, we have a quadratic function. And if we just take that left-hand side, subtract it from both sides. So we do subtract x minus 1 from both sides. Then we're going to get that 0 equals x squared minus 15x plus 48. I'm sorry, that's going to be plus 50. So we want to be careful when we have 2 minus signs turn into a positive. And then we can use any of our techniques to solve this quadratic since it's set equal to 0. So if we can use the quadratic formula right away and see that x equals, then we just plug our coefficients into the quadratic formulas. So x equals negative b plus or minus square root of negative 15 squared minus 4 A is 1, C is 50, all over 2. And then we evaluate this expression. We get 15 plus or minus square root. Negative 15 squared is 225, and 4 times 50 is 200. Still everything divided by 2. We're gonna get 15 plus or minus the square root 25 over 2, which equals, that's going to be 5 or 10. So one issue that comes up in these radical equations is that when we square both sides, we actually introduce the possibility of extraneous solutions, or that is solutions that don't actually make sense. So 5 and 10 are solutions to this equation right here, but that doesn't necessarily mean that they're solutions to the equation that we were trying to solve. So what's important is that once we find these numbers, these are what's known as our potential solutions. So now we know that if x is a solution to this radical equation, then it has to be 5 or 10. And now that we have only 2 numbers left, we can just plug them in and see what happens. So if we say x equals 5, then we'll have the square root of 5 minus 1 equals 5 minus 7. So that'll be then the square root of 4 equals negative 2. And in these problems, it's usually convention that we assume that this square root is positive. So we would have 2 equals negative 2, which isn't valid. So this is actually mostly a convention thing. There are some really high level branches of math where, particularly something known as complex analysis, where you would redefine the square root differently to make sense of what was going on. But for our purposes, and mostly the purposes of applications that you'll see in other classes, you want to assume the square root is possible. Or the square root is positive, not possible. On the other hand, if we let x be 10, then we have that we get the square root of 10 minus 1 equals 10 minus 7, or that the square root of 9 equals 3, which we know is true. So therefore, x equals 10 is our solution. And I think if you have some discontent about why we need to assume that the square root is positive when also the negative choice works as well, then maybe you're on track to being a good mathematician. Because usually mathematicians, when they see something that could work a different way and work well, they want to investigate it. Unfortunately, for the purposes of this class, we're going to stick with the practices that are typically used in applications used in different fields, such as like engineering or physics, or even business and economics. All right, and then we have one last problem. for our radical equations, and this is when we have two radicals in the equation. And so what we're still going to do is just take our radical, isolate one of them on one side. So we'll just add the square root of x plus 2 to both sides. So that way we have the square root of 2x minus 3 equals 2 plus the square root of x plus 2. And now what we're going to do is square both sides of the equation. So when we square the left-hand side, the radical just goes away and we're left with 2x minus 3, which is excellent. We've got rid of one radical. And then on the right-hand side, we FOIL it out and we get 4 plus, and then disaster strikes. We still have a square root of x plus 2, but I actually think this is going to be okay for now. And then the last term becomes x plus 2. And then we combine like terms. We get 6 plus 4 root x plus 2 plus x. And at this point, maybe you think, oh, this actually is fine, because we saw in the last equation, we know how to handle it when we have just a single square root. All we're going to do now is just isolate the square root on one side of the equation. So we'll subtract our 6 and our x over. So now we'll have x minus 9 equals 4 square root of x plus 2. And we'll also divide both sides by 4. So that way we have x minus 9 over 4 equals the square root of x plus 4. And now we have a square root that's isolated on one side. So all we have to do is square both sides of the equation. And I'm going to just jump right into expanding the left-hand side. That'll give us x squared minus 18x plus 81, all of that over 16 equals x plus 4. Which, yeah, we're looking at it and it doesn't look that fun to deal with, but I think it'll be okay. So now we just subtract our x and our 4 to the other side. So that gives us x squared minus 18x plus 81 over 16 minus 16x over 16 minus 64 over 16 equals 0. Now we have this common denominator. And so we just start to simplify. So we're going to start combining like terms. It's x squared minus 18 plus 16, which is 34x, and 81 minus 64, which is 17. And all of that divided by 16 and set equal to 0. And we just multiply both sides by 16. And we don't have to multiply each side by 16, but it clears out the denominator, so that way we just have to solve this equation. And then we just plug into the quadratic formula. So negative b plus or minus the square root of 34 squared minus 4 times 1 times 17 all over 2, which is 17 plus or minus the square root of 34 squared minus 34 times minus 68 over 2. And this would be a good point to pull out your calculator or just plug it back in and check to see if it works. These are, of course, or this is, of course, kind of an ugly number, but that's okay. It still works as a solution. And that's that. All right, so now I think it'd be best to go out and just practice radical equations. Go try 3 or 4 on your own. There's some in the homework, and there's also just extra ones in the textbook. All right, thanks for watching this installment of College Algebra.